Hi everybody, welcome back from coffee. I hope everybody's recaffeinated. So our first speaker of the session is Nathan Cheng. So Nathan is the Program Director of On Deck Longevity Biotech. He is the co-founder of the Longevity Biotech Fellowship and a general partner at HealthSpan Capital. He's also the founder of Longevity Market Cap, which is one of the most widely read newspapers on investing in longevity, as well as Longevity List, which is a database of companies and a jobs board. Nathan obtained his master's degree in physics from the University of Toronto, where his research focused on quantum control of ultra-cold atoms. He was awarded both the CGS Masters and CGS Doctoral Graduate Scholarships from the Natural Sciences and Engineering Research Council of Canada, but dropped out of his PhD program to pursue other goals. I'm part of the ODLB Fellowship, and so I want to say thank you for creating a really amazing, smart, energized, longevity-focused group of people in San Francisco. Really excited to hear him talk about an update on the state of longevity this year. Would you like to?
Okay, yeah, thanks for the introduction, Eddie. And thanks, Kristen and the team at the Buck for putting on this awesome conference. It's been really great. Okay, so yeah, a little bit about myself. Well, let's get the clicker here. So actually, fun fact, actually, my full-time job is actually acting as Matt Caberline's personal fashion stylist. Yeah, that's my main occupation right now. But seriously speaking, yeah, so right now I'm working as the director of the Longevity Biotech Fellowship. It's the spiritual successor and nonprofit to the ODLB program that I've been running for the past year. And I'm also a co-founder at HealthSpan Capital. But before all of that, I got really obsessed about longevity and longevity biotech, and created this database, the Longevity List, which is also a jobs board. So if you're looking for a job in the longevity biotech industry, definitely check it out. And yeah, so basically I've been, for the past couple of years, just obsessively collecting data and looking at trends in the longevity biotech industry. So this talk is just going to be sort of an overview of what's going on in the space, how we got here, what it's like right now, and where we're going in the future. Okay, so moving right along. Okay, so basically, I'm just going to cover four things. The problem of aging, sort of like the obligatory slides, and then talk about a little bit about the history to give you a bit of context of how we got to where we are now, and then just look at some of the sort of stats and trends that are sort of relevant to the longevity biotech industry today, and then just a couple words about the future. So, the problem of aging. I am just going to plainly assert, without justification, that involuntary death is a bad thing, generally speaking, and it's a moral good to try and reduce that as much as possible. And so if you're trying to do as much good as possible to reduce involuntary death, you might ask yourself, what are the things that cause the most deaths, right? So does anyone know what like the top causes of death are in the United States? Like in cardiovascular disease, I heard cancers, anything else? COPD, yeah, okay, yeah, very good. So, yeah, top 10 causes of death in the US. If you look at them, yeah, cardiovascular disease, other chronic diseases, but one thing that unites all of them, right, if you're trying to find some commonality between these diseases, is that most of them are related to aging, or in the sense that the risk factors for developing these diseases increase exponentially with age. So this is suggestive of something, right? If you see these diseases that kind of look different, right? They manifest in different ways, but they have this commonality where the dynamics, as you get older, you become more susceptible to these diseases. Maybe there's something that you could do to target all of these diseases by targeting the common factor, which would be aging, right? So basically a new wave of biotech startups are trying to do exactly this, right? Instead of trying to target individual diseases in different ways, maybe you could try and target all of these diseases of aging by targeting the fundamental cellular and molecular mechanisms of aging. So that brings us to a definition, okay? What is longevity biotech? I mean, when it comes to longevity biotech, some people like using this word, other people like using aging biotech, other people are more interested in rejuvenation, other people are going to use the word health span. There's no real common agreed consensus on what this definition is, what it is, and which companies actually belong in this moniker of longevity biotech, and which ones are outside of this group or definition. But I would just assert maybe a good starter definition would be just longevity biotech is the development of therapies that can treat or prevent multiple age-related diseases at the same time, and thereby increasing healthy lifespan. And you would do that by targeting cellular or molecular mechanisms of aging. Now, there's a little bit of play in this definition. So does regenerative medicine fit into this category, right? Does all of regenerative medicine fit into this category? And what about diagnostics? So people developing aging biomarkers, biological age clocks, and so forth. Does that also fit the definition? Well, I think for myself, I'm mostly focused on therapeutics. So for the rest of the talk, I'm just going to talk about that. And yeah, when it comes to regenerative medicine, I think it broadly falls into the definition, but we'll talk a little bit more about that later. Okay, so let's just quickly talk about the history of longevity biotech. How did we get here? So you can sort of see how sort of like a timeline of some of the major milestones, in my opinion, of how this field developed. It goes way back to sort of like the beginnings of the molecular biology of aging and certain discoveries there, and then the first wave of startups, and then growing legitimacy, and then in 2016, kind of like an explosion of different approaches in the aging space, and then where we are today. So yeah, let's quickly just talk about where we trace the origins of longevity biotech. So it goes back to discoveries in the 80s and 90s, basically the first discoveries in the molecular genetics of aging. So the work of Cynthia Kenyon and Tom Johnson in C. elegans, finding single gene mutations that could increase the lifespan of C. elegans. And then also the work by Carol Greider and Elizabeth Blackburn in the discovery of telomerase, which is the enzyme that lengthens telomeres. And then some more controversial stuff going on in the Grente lab, looking at sirtuins and their relationship to lifespan and aging in yeast. Okay, so out of those beginning discoveries came the first wave of longevity biotech startups. So there was 3 startups, Geron, Elixir, and Sirtris. So Geron was co-founded by Mike West, Elixir Pharmaceuticals, co-founded by Cynthia Kenyon and Lenny Guarente, and then David Sinclair co-founded Sirtris Pharmaceuticals. And they were basically, each company was going after one of these sort of targets or longevity genes. So there was a lot of hype, especially when it came to Sirtris, because they were trying to essentially activate sirtuins using compounds similar to resveratrol, which is an antioxidant that is found in red wine. And of course, journalists picked this up. There was a lot of news coverage around this, and eventually culminated in GlaxoSmithKline acquiring Sirtris back in 2008 for $720 million. So that was huge. But unfortunately, fast forward a couple of years, the first wave of longevity biotech startups actually kind of fizzled out. Geron is still a company today, but they've mostly pivoted away from aging. Elixir Pharmaceuticals eventually closed up shop. They were unable to broker a deal with Novartis. And then, of course, Sirtris, there was a lot of controversy around the underlying science there. And then there was issues with the clinical trials with certain side effects with the sirtuin activators that they were testing out. And yeah, so the first wave of startups sort of fizzled out. And I guess lessons learned, basically, translating therapies from longevity science is hard. And it's not going to be a straightforward path. Yeah. But not to be sorry. Okay, train of thought. Okay, yes. Okay, so it was not all bad news. It was just the beginning of actually the revolution. So in 2013, this was a milestone year in the longevity biotech industry because certain players got into the space and sort of lended more legitimacy to longevity as a subfield in biotech. So in 2013, there was two big announcements. So there was Google's Calico, an anti-aging play, and that was headed by Art Levinson, who was a former CEO of Genentech, right, which is the company that started biotech. So obviously a really well-known figure in the space. And then Craig Venter, obviously really well-known for his work in the Human Genome Project and his company Celara. And yeah, basically this sort of normalized that it was okay to work on longevity. It's not just like this snake oil sort of idea that you can actually develop companies in this space. Okay, so moving right along. So in 2016, more approaches started to crop up in the longevity biotech space. It was no longer just like the first sort of longevity genes. There was all sorts of different approaches and targets in developing therapies to target aging. And you can see in this graph, basically, it shows how many new startups were created in the aging space across time. And yeah, definitely around 2015, 2016, there was a large uptick in the number of companies. The data is not complete because a lot of companies are actually still in stealth. I'm always adding new companies that even were incorporated in 2019, but then announced until like many years later. So so if we're looking at the approaches that cropped up, I'm just going to name a couple subcategories. If your favorite category is not there, don't be mad. But obviously, some of the bigger ones, senolytics, so removing senescent cells that lose the ability to divide. There was a really landmark, a landmark paper was published in 2016 by the Mayo Clinic, which basically showed that when you remove senescent cells, you could increase median lifespan in mice, and also there was like a very clear difference in aging phenotype between the treated mice and the untreated mice. And then also in 2016, Ocampo and Belmonte at the Salk published their landmark paper in cellular reprogramming, partial reprogramming, basically leveraging some of the techniques from induced pluripotency to turn back the state of a cell, at least the epigenetic state, to resemble more a youthful phenotype. And yeah, they were able to do this in mice in vivo and extend the lifespan of a progeroid mouse model by about, I think it was 20% or so. So yeah, and then there was other approaches, obviously parabiosis. We had a fantastic talk earlier from the folks at Alkahest, and then also Allevian is a company that's developing a factor found in circulating in blood, GDF11. And yeah, basically the idea is that there's factors in young blood and old blood that might have an effect on aging. And then, of course, there's mTOR, everyone's favorite targets, and also companies developing therapies to extend lifespan or health span in pets, which might be an easier way to demonstrate efficacy. Okay, because pets can live for a shorter amount of time. But, of course, there's a bunch of other interesting approaches, anything from like AI, machine learning, autophagy, mitochondria, telomeres, and all the people working on epigenetic clocks and so forth. Okay, so let's continue. Okay, so let's talk about the longevity biotech landscape today. If I could summarize basically the major themes in 2022, it's basically there's been a lot of big headlines about major funding in the space. But I would also caution to say that, you also have to zoom out and look at, the scale of this funding compared to the scale of the problem of aging and even the scale of just other areas in biotech. So even though it's been a lot of money, like in the newspapers and the headlines, it's still pretty small comparatively. So let's dig a little deeper. So most of this data is taken from my website, Longevity List, but we also have an amazing database by Carl Flager at agingbiotech.info, which you should also check out. Yeah, so basically, if you count the number of biotech startups that fit my definition of longevity biotech, it's about 160 startups. And across those 160 startups, it's about $13 billion in funding. The valuation, if you were to estimate the valuation of all those companies, is probably less than 50 billion. But in 2022, we've already had more than $3 billion of funding. Clinical trials, there's about 40 or so clinical trials being conducted by these companies, and there's about 20 or so longevity-focused VCs operating in this space. Okay, so let's talk about funding. As you can see, there's been a massive uptick in funding since, I guess, 2021 and 2022. A lot of that has to do with Calico and Altus Labs, which Altus Labs maybe is not a longevity company, maybe. Anyways, so it's roughly a 7x increase over the last 7 years, okay? And, okay, let's take a look at startup funding by subcategories in longevity biotech. So as you can see, cellular reprogramming, partial reprogramming is overrepresented here. There's a lot of funding in that regard. And even mitochondria and regenerative medicine are highly funded. But if you look at the categories that are not really funded very much, reproductive aging, extracellular matrix, DNA repair, those are potentially areas that could benefit from more funding. Okay, so let's take a look at top funded startups, excluding Calico and Altus Labs. So you can see some of your favorite names here, BioAge, of course, Retro Biosciences. But if you include Calico and Altus Labs in this graph, then it looks much different, okay? So yeah, Calico and Altus Labs represent about like 50% of all the funding that has gone into private startups in this space. So there's a lot of concentration. Okay, let's quickly just talk about what does the investor space look like. So in 2011, Laura Deming started the first longevity VC firm, and she started with just a fund of $4 million, right? And that was in 2011. But then fast forward 10 years, you have like giants like Apollo Health Ventures, which recently closed a $180 million fund. There's actually several VC firms that are specifically focused on longevity that have over $100 million in funds raised. And then we have entries from even bigger players. So Evolution, Saudi Arabia, that announcement this year was huge, and they're slated to invest up to $1 billion a year into this space. I think 2/3 of that is going to be actually academic grants, but then 1/3 of that will be in startups and private companies. And then, of course, a huge shout out to the folks at VitaDAO, spearheading sort of a different model of being able to fund companies and research in this space with decentralized autonomous organizations in the Web3 sort of paradigm. Okay, so moving right along, here's just like a landscape of the sort of investors in the space. I also include distributed companies. So we have James Fire here from Cambrian. Basically, these are like portfolio companies, umbrella companies that have multiple companies in their portfolio, kind of like in a hub and spoke model. But then you have longevity-focused VCs, and then you also have VCs who are more traditional, who invest in a lot of different things, but have maybe a longevity theme as part of their broader investment thesis. Okay, so let's talk about some trends in 2022. As I said before, cellular reprogramming is just the hottest space in longevity biotech right now in terms of funding. We have, I won't dwell too much on this, but yeah, basically the companies involved in reprogramming include like HX Therapeutics, Turn Bio, Retro Biosciences, obviously New Limit, Altus Labs. And they're all basically trying to reset the epigenetic state of the cell, but not all the way back to an iPSC or stem cell, but to something of a more youthful state in a technique called partial reprogramming. And yeah, so there's a lot of news around these approaches. Altus Labs launched earlier this year with $3 billion in funding, backed by, allegedly, by certain Silicon Valley billionaires. But then it's not just Altus Labs, it's also Retro Biosciences, which launched with $180 million. Brian Armstrong, one of the founders of Coinbase, Also started his own company in reprogramming called New Limit with $105 million. And right now, it looks like the general theme for reprogramming is there's certain companies trying to do partial reprogramming with OSKM, the Yamanaka factors, or some variants of the Yamanaka factors. But then there's this whole other sort of space race for rejuvenation going on as well, looking for novel reprogramming factors and rejuvenation factors. So a lot of the more well-funded startups are trying to mine that space. And yeah, so it's going to be interesting to see how this all pans out in the next 5 to 10 years. Okay, so let's quickly talk about clinical trials. Yeah, so there's about 40 or so clinical trials being conducted by companies today. And most of them are trying to test geroprotectors or anti-aging drugs in age-related diseases or rare diseases, usually going after a smaller indication first and then label expanding to other broader indications. There's also a possibility for doing something like a TAME trial where you're trying to prevent multiple, or delay rather, the onset of age-related disease. So that's another way to potentially demonstrate that your drug is indeed sort of a geroprotector. But there's zero approvals so far, right? We're still waiting for our 0 to 1 to prove out this industry. And there's glimmers of hope. So we have BioAge, which just recently announced some data, so positive phase 1b in their muscle aging drug. So that's amazing. Huge shout out to them. And then Unity also this past summer announced some positive phase 2 trials for their positive phase 2 data for their drug treating diabetic macular edema. So it's a drug that removes senescent cells. Yeah, so some other trends that we're seeing, big pharma interest. So Pfizer Ventures made an investment in VitaDAO. So that was really big news. So very cool to see big pharma get into the aging space in that way. And then also there was some news about potentially Genentech getting involved in reprogramming as well. Okay, and we already discussed this, but big funders, I think this is going to be a theme going into the future as well, where, whether that's sovereign wealth funds or other larger entities getting involved in this space and investing in a big way. So excited to see that. Okay, so a couple last words about the future of longevity. So broadly speaking, as we extrapolate sort of the present trends, we're going to see more human data, right? So more clinical trials. And a lot of the companies that were started in the past 5 years are eventually going to get to the clinic, and then we'll see, whether this geroscience hypothesis or paradigm will translate. And then another thing that I think will be really interesting to see is like a geroscience moonshot. So Matt Kaberlein has wrote an amazing piece in The Hill, basically advocating for some sort of large allocation of resources, maybe from the government, maybe through a private initiative, to really focus on geroscience. And then I really like replacing aging, this paradigm where instead of trying to fix all the damage or understand the metabolism of aging, maybe there's some interesting approaches in regenerative medicine, which could be really impactful. And then longevity on the label, I think what people are doing at the Dog Aging Project is really cool, and we might be able to see the first sort of indications where you can prescribe a drug that can provably say, that it extends lifespan in a furry family member of some sort, okay? And there's also a couple of different companies working on the pet longevity space as well. Okay, so just to wrap it up, so as I said before, it's great to see all this funding in this space, and really excited. It's increased a lot over the past couple of years. But compared to the size and scope of the problem, and even compared to the size of other areas in biotech, longevity is still really small. So if you look at maybe valuation estimate, if you look at all the public companies in pharma and biotech, it's roughly $5 trillion, which is more than 100x what the total combined valuations of longevity biotech would be. If you look at just private funding in terms of the startup space, between 2017 and 2021, Only 3.6% of private startup funding went to longevity biotech, despite the fact that, as we said before, most of the diseases that end up killing us are caused by aging. Okay, so if we want to make a major move on aging, what would you need? People talk about geroscience moonshot. Well, does anybody know how much the Apollo program costs, or how many people were working on it? Any estimates? Anyone? Nice, yeah. So yeah, in today's dollars, the Apollo program cost about $250 billion, so $250 billion. So I assume that, making a major dent on aging is much more complex than going to the moon. So we'll probably need to galvanize some sort of, equal magnitude of resources in human capital, but also financial capital towards this. So something to think about, okay, as we think about scale of the problem and what's going on in the space right now. Okay, so last thing, I'm just going to wrap up. I know Kristen's probably watching my time, but so one thing that I'm trying to do to get more human capital working on the problem of aging is this new nonprofit community called the Longevity Biotech Fellowship. It's the spiritual successor to what we've been doing at OnDeck. And we just launched a couple of weeks ago, and we're looking for talented people who really want to get involved in working on aging, mostly in the context of biotech startups. So if you're interested in doing something about aging, I encourage you to apply. So that wraps up my talk. Thank you. So there's a question.
Hi, great talk. Loved it. Okay, so IP NFTs. Can you explain how this funding model works and why everyone is so excited about it? And I realize that we might have a timing problem, so if you can't do it in like 30 seconds, maybe you can just explain it to me later while we're drinking.
Yeah, okay, so I'm not an expert on this either, but you can talk to Max over there, Max Unfried at VitaDAO. Maybe he can explain it a little bit better. But I guess like the quick 30 seconds is that instead of just having all this IP sitting around at like a tech transfer office where it's like really opaque, what if you could tokenize that IP, the contract of the IP on a blockchain where it's openly transparent and I guess transferable in a marketplace? And then maybe that's a way to, I guess, reduce friction in spinning out some of this IP for applications and companies and stuff like that. Did I get that right, Max? Okay.
Okay, thanks, and I will talk to you later.
Okay, awesome.